Hello everyone, my name is Tasneem Safdari and in today's video I am going to explain question number 6 of end semester paper. In the previous videos I have explained till question number 5. So let's start with question number 6 in particular video. I'll be explaining both part A and B in this particular video. So let's start. 6a, how are missing values handled, suggests three approaches. When we have data set, there are certain missing values in it or duplicate values. So how could we handle those values? So missing values are very common in data sets, especially in real world application like text mining, data mining, machine learning, surveys, etc. Handling them properly is important because missing data can reduce model accuracy and create bias. So we could have the result will be biased or towards one person if we have missing values. So below are three widely used approaches to handle missing values explained clearly and in detail. So first is deletion method, which is removing missing data. So list-wise deletion. Remove any row record that contains at least one missing values. Only complete records are used. So we will remove any particular row which contains one missing value. What are the advantages? It is very simple to apply, no distortion to remaining data. Disadvantages: risk of losing a large amount of data. If a particular column contains missing value and we are removing the whole row, the important information could also be deleted. Works only if missing percentage is very low, that is below 5%. Example, if a data set has 100 rows, 10 rows have at least one missing values, those 10 rows are removed. Then pairwise deletion. Use all available data by considering only non-missing values for each calculation. When used mostly for correlation or covariance calculation. Then imputation methods, which is filling missing values. So here we replace missing values with some estimated values. So rather than removing whole column or a row, not a column but a row, we can fill in those missing values with some other values. For example, mean, median or mode imputation. Mean for numeric continuous data and median for skewed numeric data. Mode for categorical data. Advantage is very easy and fast. So mean is for numerical data which is continuous, median is for skewed numerical data, and mode is for categorical data. So it is very easy and fast, maintains data set size. Disadvantage: reduces natural variability and may introduce bias, because naturally if the answer would be different but we are filling it with mean, median or mode, so its answer may be variant. There will be variability in the answer and may introduce bias. For example, if age values 22, 25, 27 missing, replace missing values with mean age. Like k nearest neighbor, which is KNN imputation. So find the k most similar records based on other features. So we'll find the k similar records and replace the missing value with the average or most frequent values amongst those neighbors. So finding neighbors and then filling in the missing values with average or most frequent value of amongst those neighbors. So it is more accurate than mean, median and captures relationship between variables. Disadvantages: slower for larger data sets. When we have large data sets, it becomes slow and sensitive to outliers. Third is regression imputation. So predict the missing value using a regression model trained on other features. Example, predict missing salary using features like experience, age, education. Okay, so we'll predict missing salary like experience, age, education. So we are doing a prediction here. By regression model, we are predicting the values. Pros: more realistic estimation because we are using other features to estimate our answer. And cons: can artificially increase correlation. Third is using advanced techniques like model based or ML based. So multiple imputation. Create several imputed data sets using probabilistic models. and combine them to reduce bias. Then B is using algorithms that handle missing values automatically. Some algorithms can handle missing value internally. There are features, there are certain models or algorithms which handle the missing values. Random forest, XGBoost, Light, GBM. And advantage is no manual imputation is required. Manually we don't have to find values and impute it, means put it in those place, but it does it with algorithm which finds the missing value and substitute it in its particular value. So the three approaches are deletion, which is removing the missing data, and imputation is replacing the missing values, which can be done with mean, median, mode, KNN imputation or regression imputation. And third was model based handling, in which we have used advanced techniques with there are algorithms which fill in the values by finding certain patterns, or particularly of which algorithm is designed. On that basis it fills in the missing values. So we have machine learning models that automatically handle that missing values automatically, like random forest, XGBoost, similarly those handles. Okay, so this was all about part A of question number 6. Now let's move to part B. Explain logistic regression and use the logistic function to calculate the probability of a class for a given input. Example. So what is logistic regression? Logistic regression is a supervised learning algorithm used to classify things into two categories, which is binary classification. So it is a supervised learning algorithm. We have seen what is supervised and unsupervised learning algorithm. So it is used to identify things into two categories, which is known as binary classification. So example, we have email. So email can be spam and not spam. Customer, will buy, will not buy, and review can be positive and negative. So if it answers the question, what is the probability that this input class belongs to class 1. Okay, so why not use linear regression for classification? Linear regression gives output like 5, 10, 500, etc. But probabilities must be between 0 and 1. So in the place of logistic regression, we could use linear regression as well. But it gives the output, which is the output should be, probability should be between 0 and 1, and linear regression usually gives different values like 5, 10, 500, which is not in between 0 and 1. Logistic regression solves this by using a special S-shaped curve called sigmoid. Another core idea takes input features, example age, income, marks, and then combine them like a weighted sum. So it combines them, pass the result into a sigmoid function which converts any number into a probability between 0 and 1. If the probability is greater than 0.5, predict class equal to 1, and if it is less than 0.5, predict class equal to 0. That's it. It is a simple idea that it takes the input features, combine them as a weighted sum, and then pass it into sigmoid function which converts into probability of 0 and 1. And if the probability is greater than equal to 0.5, predict class equal to 1, and less than 0.5, predict class equal to 0. So what is the sigmoid function? Sigmoid function simply squeezes any value into range 0 and 1. Big positive number becomes close to 1, and big negative function becomes close to 0, and 0 becomes 0.5. Think of it like a threshold smoother. So it is a function which squeezes the value between 0 and 0 to 1. So if it is a very big positive number, it becomes close to 1, and if it is a very big negative number, it becomes close to 0, and 0 becomes 0.5. So how logistic regression make prediction? Suppose we want to predict whether a student will pass, which is 1, or fail 0 based on study hours. So we have learned a model with weight of study hours equal to 2 and bias equal to -3. So we'll compute score. So score will be equal to weight into input plus bias. So input is weight 2 into study hours minus 3. So pass score through sigmoid. Sigmoid converts this score into a probability. If probability is greater than 0.5, it will predict that it is pass, and else it will predict it is fail. Like whether numerical example, predict whether a student will pass if they study 3 hours. So weights is 2 and bias is -3. So calculate score 2 into 3 minus 3. So 6 minus 3 is 3. So convert score to probability using sigmoid. Sigmoid of positive value becomes closer to 3 because sigmoid is 3. So it will become closer to 1. So 0.95. This means probability of passing is 95%. Decision probability 0.95 is greater than 0.5. So the predict class equal to 1. So this was how we solved the logistic regression example. Why is logistic regression popular? It is easy to understand and it is fast to train, because if we have only 0 and 1 values are in between those and probabilities between those values, and we have to predict accordingly. And provides probability, not just labels. Works well for many problems and avoid extreme outputs like linear regression. So where is logistic regression used? It is used in spam detection, email classification, disease prediction, customer churn prediction, text mining, and fraud detection. So these are the places where logistic regression is used. For spam detection, email classification, disease prediction, like we have seen in question number 1, that customer churn prediction. So these are the places where logistic regression is used. The summary: logistic regression takes input features, creates a score. It creates score, converts score into probability using sigmoid, and decides class based on probability. Used for 0-1 classification. When we have two values between 0 and 1, at that time it is used. So this was all about part A and B of question number 6. We have discussed everything in detail. I've tried covering every topic, and the next videos will be discussed in next videos. I hope you liked it. Thank you so much for watching.